how can Boole not have an influence on space exploration? I mean, Boolean algebra is the basis for computer language. The logic of it, the ones and zeros, the and, or not, that language equated to how we do computers. And it's computers that allowed us to go to the moon.
The key ideas that made Boolean algebra relevant for engineering was Claude Shannon. And actually in 1938, he wrote his master thesis at MIT. And in this master thesis, he showed that you could analyze network of switches using Boolean algebra. And that was the aha moment for engineers who followed, in the sense that transistors, when they became viable and they were developed at Bell Labs later on, then could be considered as switches. And so all of a sudden there is this one-to-one correspondence between transistors and element of Boolean algebra, and that made computers, the hardware of computers, realizable.
To me, as a mathematician, it's even more fascinating what Boole did than as a computer scientist or as a communication theorist. I mean, for mathematicians, you're trying to deal with the concept of truth, and truth is a 0 or 1 concept. And Boole was the first person to realize that this whole endeavor that we are going through is itself subject to the rules of mathematics.
So Boole was really the guy who had this fantastic idea that we could study zeros and ones, and that would and we could get a tremendous amount of mileage out of zeros and ones. So he writes this equation, x squared equals x, and he knows that there's only two numbers that satisfy this equation, and there's 0 and 1. So now comes the punchline. Let us conceive then of an algebra in which the symbols x, y, z, and so on admit indifferently of the values 0 and 1 and of these values alone. There it is. I mean, that's golden. It might seem trivial, but he mentions you got x, y, and z, etc., and that's what's in the computer. You've got x, y, and z, and etc. A billion of them in there, and he says, how are we going to deal with any number of things that are all zeros and ones and how they interact with each other?
If you look at the history of automated reasoning, he was on the very early side, but many of those who came after him built on his work. And especially, I think, the way he was thinking about things was very ahead of his time. Thinking about, how do we mechanize this process of reasoning? How do we put it on a solid foundation? And even how do we do reasoning by manipulating symbols? That was a very new idea. And of course, absolutely fundamental to automated reasoning and the success that we're having there today.
Well, he did win a gold medal from the Royal Society for his paper on a general method analysis. He introduced operator methods into calculus. He founded a new branch of mathematics, invariant theory. He did very good work on differential equations. But for all these contributions, you would rate George Boole as a fairly good, not terribly outstanding, but a good, solid 19th century mathematician. I think what Boole did, who was also a fellow inhabitant of Lincolnshire, as Newton was, is comparable in mathematics to what Newton did in physics. That he saw this phenomenon and that he formulated it in mathematical terms. Simplicity is there all the time, and that takes great genius.
Boole must have been really a phenomenal person. For what he achieved, he didn't have formal education. He'd not been subject to the same kind of peer learning that we all are. So he really must have been an individual genius, and I think his work reflects that.
And within a few weeks, he had all the ideas for his first book. It was just amazingly quick, nothing like what anybody else was doing to bring in equations. And then to go as far as he did, I mean, he didn't just have the basic ideas, he had plan for what should be done with the subject. What were the goals? He laid them out. And by 1854, he had accomplished them. Amazing.